Hey guys, back here with another theorem. This week might be a bit experimental, I guess. What I'm going to do is just pick the first theorem out of every book I have, and we're going to, talk about it for a bit. Okay, so this theorem is the classic Cauchy-Schwarz inequality. So we have X is some inner product space, capital X. So an inner product space is just a vector space equipped with some sort of inner product, which this book denotes with parentheses. Oftentimes you'll see it with, say, angled brackets. And you take two vectors in this vector space, x and y, obviously, for instance. And from here you take the norm, you take the magnitude of the inner product of x and y, and you know that that's less than or equal to the magnitude of the norm of x times the norm of y. So this theorem is pretty central to, pretty much all of when you're algebra, physics, quantum mechanics. You'll see it everywhere. And it basically just says that the size of two vectors is always going to be greater than the projection of one vector onto the other, which of course, makes sense. Right, and there's only an equality in the case that x and y are linearly dependent, i.e. that the dot product, or inner product, between x and y is just going to be equal to x times y, which happens when you have two vectors that are in the same direction. Okay, so I'm not going to prove this, but I'm sure you can find it.